All right, today we're diving into the story of a hidden, almost magical little component that powers pretty much everything that spins in our world. So, let's get rolling.
First, I want you to do something for me. Just imagine a world. A really frustrating world. Yeah, a world where your bike, your skateboard, even your car, the wheels just won't spin. Instead of gliding smoothly, every single movement is a total battle. You push, you shove, and all you get is this awful, scraping, grinding, squeaking noise. Nothing moves easily. So why? Why is this world so stuck? What tiny, crucial piece of tech is missing from this picture? Well, the answer introduces us to the villain of our story.
And that villain, that universal force that's always trying to stop everything in its tracks, is friction.
So what exactly is friction? You know, the best way to feel it is to just rub your hands together really fast. Go on, try it. They get warm, right? And you feel that little bit of drag. That warmth, that resistance, that's friction in action. It's simply the force that happens anytime two surfaces rub against each other. Now, friction can be useful. It's why our shoes grip the pavement. But inside a machine, oh, it's a total disaster. It wastes a ton of energy by turning it into useless heat, it makes parts wear out way too fast, and its #1 goal is to slow everything down to a grinding halt. So yeah, we needed a way to defeat it. And this is where our hero enters the story. It's small, you almost never see it, but it's incredibly mighty. An invention designed for one purpose, to conquer friction. This little device literally set the wheels of the Industrial Revolution in motion. So let's meet the bearing.
So what is a bearing? Well, simply put, it's a part that's designed to let things spin smoothly by cutting down on friction and carrying weight. Its whole job is to make things move, well, smoother.
And the design of our little hero is deceptively simple. Most bearings have just a few main parts. There's an outer ring and an inner ring. Sandwiched right between them are the most important bits, the rolling elements, which are either tiny balls or little cylinders. A cage keeps them all perfectly spaced out, and a little bit of grease makes sure everything stays slick and smooth. Okay, so how does this simple device perform what seems like a magical feat? Well, the secret isn't magic at all. It's just some really clever physics. It all comes down to its rolling superpower. And this right here is the big aha moment. Think about trying to push a heavy box across the floor. It's hard work, right? That's sliding friction. But what happens if you put a few pencils under that same box? Suddenly, whoosh, it glides across the floor with almost no effort. That's because you've replaced that awful high-friction sliding with easy, low-friction rolling. And that is exactly what a bearing does. It takes two surfaces that would normally scrape and slide, and it puts tiny little rollers between them.
But here's the really cool part. Just like in superhero movies, there isn't just one hero. Oh no, we have a whole team of them, and each one has a special skill for a different kind of job. So let's meet the team. First up, we've got the most common type, the one you've probably heard of, the ball bearing. These are the speed demons of the mechanical world.
Because these bearings use little balls, they have a tiny point of contact. That means very little friction, which allows them to spin incredibly fast. They're perfect for things like bicycle wheels, skateboards, and computer fans. And you know that super long, satisfying spin you get from a fidget spinner? Yep, that is pure ball bearing magic at work.
Okay, but what if you need to move something really heavy? For that, you call in the powerlifters of the group, roller bearings. Instead of tiny balls, these use solid cylinders, or rollers. This gives them a much larger surface area to distribute all that weight. Think of it like this. A ball touches the ground on a single point, but a can of soup lays flat and spreads its weight out. That's why roller bearings can handle the immense weight of things like train wheels, elevators, and massive factory equipment. They trade a little bit of top speed for incredible strength. And finally, we have a specialist on the team. What about forces that don't just push down from the side, but push from the top or bottom, right along the axis of rotation? For that, you need a thrust bearing. Think about a spinning bar stool. As you sit and spin, your weight is pushing straight down on the rotating part. A thrust bearing is designed specifically for that kind of load, which pushes parallel to the shaft. You'll find them in car steering systems, turntables like a Lazy Susan, and even the giant rotors of a helicopter. They are the unsung heroes of anything that has to spin under pressure. So let's quickly recap this heroic team. To understand their strengths, you just need to know two types of forces, or loads. Radial load is the force pushing down on the bearing from the side, like the weight of a car on its wheels. Axial load is a side-to-side force, or a thrusting force from the top or bottom.
So the ball bearing is our speedy all-rounder, handling both. The roller bearing is our heavyweight champion, specializing in heavy radial loads. And the thrust bearing is our vertical specialist, built to handle heavy axial loads, that pressure from above and below.
You know, the most amazing part of this story isn't just how they work, but where they are. Once you start looking, you realize these tiny heroes are absolutely everywhere, making our modern world possible.
They're in your car's wheels, supporting thousands of pounds. They're in your bicycle, making every pedal stroke effortless. They're in your washing machine, your ceiling fan, even the hard drive of your computer. They're in the powerful engines of a jet and the silent solar panels of a satellite in space. They are the true unsung heroes of motion.
And if you take away just one thing from this explainer, let it be this simple idea. Bearings use tiny balls and rollers to turn rubbing into rolling, making wheels spin easily and machines work smoothly. It's a beautifully simple solution to a massive problem.
So I'll leave you with this. Look around you, right now. What's spinning? A fan, the hard drive in your computer? Whatever it is, know that a tiny, hidden hero is inside, silently winning the fight against friction and making your world go round.